Okay, so our session today is called WTF. That's not what you're thinking. It's a web application firewall testing framework. And my name is Amkan Shilman. I've been doing information security for almost 20 years now. Past 10 years, the major focus of my research and my group is application security and database security, not so much on the infrastructure side. Yaniv here, again, a team leader in our research group, and has been credited with a number of Oracle database vulnerability discovery. He's just released a free product called Scuba 2.0, which is a free database vulnerability assessment tool, and has experience in developing web application as well as database security products. Well, we have a large agenda today. We want to talk about web application firewall evaluation. And first and foremost, we want to see why we want to evaluate web application firewalls, and then what we currently do in order to evaluate them and what are the shortcomings of those methods. And then we will see what is actually missing in our current practices. Then we'll introduce our web application testing framework. We'll talk about the concept, the architecture, a short walkthrough of the user interface, and a little bit about future plans for this framework. After that, we're going to see a live demo of the web testing framework. In practice, we're going to test two different solutions with it. One is an IPS, the other one is the web application firewall, and then end up with a summary and conclusions. So, web application firewall evaluation. Why are we doing that? So the first reason for us to evaluate is to make sure that we buy the right stuff, okay, that it has the right feature set for us, and that it performs and scales up nicely for our needs. And then, of course, we want to know that we are buying a quality product, and with a security solution, quality means, to some extent, the level of protection that you get from that product. And then we'd also like to be able to evaluate our deployment. So make sure that we optimize our deployment for a given environment. Okay? And quite interestingly, there's a quote here from a recent blog series by AppSecUSA analysts, and they're saying that most of the users that they have surveyed found that their problems are not stemming from the quality of the product that they have purchased, but rather from the ineffective management. So we need a tool that would allow us to evaluate how we deploy the web application firewall. What are the ways that we're using today in order to do that? Well, the first common practice is ask the vendor. Now, I'm a web application firewall vendor, and you can ask me, how good is our web application firewall? I'll say it's the best. It has no false positive. It has no false negative. It doesn't get you that far, And then there's WAF, which people here are probably familiar with, which is an improved version of Ask the Vendor, because now you have a checklist, and all the vendors actually agreed on a common checklist, and you can just pick and choose whatever features you want to cover, and you'll have the vendor answer whether he supports them or not. Now, I think that the most common practice today is security benchmark products, like the one we have from Breaking Point or Spirent. I think Spirent used to be New Security, the tool that they're using. These are tools, actually hardware packages, that just play traffic on the network, attack traffic, and that's important. They play attack traffic on the network against a virtual server, and they measure how much of that traffic gets blocked by the tested device, whether it's an IPS, a web application firewall, an antivirus gateway, everything. They test everything, and that's really the issue. They're focused on quantity and the breadth of the offering rather than the quality and depth of the test. So they have vulnerabilities from each and every protocol and each and every product out there, and they are testing web vulnerabilities and server-side vulnerabilities together with client-side vulnerabilities, all in one package. And really, their competition is about covering as many vulnerabilities of as many protocols as possible. And you pay in the fact that they're not focused on application security. If you look at their support for evasion techniques in the application layer, it's very poor. If you look at their ability to, for example, simulate stateful attacks, it's very poor, okay? And we'll talk about that, we'll emphasize that. And eventually, when you use this tool and you want to end up saying, well, is that a good web application firewall? It needs to block all the traffic generated by the tool, okay? And that's important. So just to give you a quick idea about stateful vulnerabilities, here's sample traffic that I took when using Breaking Point, okay, to test a web application firewall. And all these three samples are cookie tampering vulnerabilities. Okay? Cookie tampering vulnerabilities mean that I received the cookie from a server and then I changed it. But all the traffic here indicates a single request from the client to the server. So how can it represent anything that is stateful? Okay, three different vulnerabilities here. So there's clearly an issue here, and we'll demonstrate it later. The last practice that people use to evaluate their web application firewall is using a web vulnerability scanner. Now, these are great products that require a lot of effort in order to really get meaningful results in terms of knowing what the state of your application is. It's even more difficult to test a device in the middle, because eventually you need to trust the tool to get good coverage of the application, and really to some extent that you'll have a very vulnerable application, because otherwise you don't know whether it was the web application firewall who mitigated the attack or the application wasn't vulnerable to begin with. And again, the bottom line is that you test the WAF by looking at the final report and saying, well, I have no vulnerabilities. Okay, so you don't know whether there were any vulnerabilities to begin with, or whether your WAF is blocking everything, or whether you were not able to detect a vulnerability in your application. And in general, the common theme among all those methods is that a WAF with the following behavior would consider to be a very good web application firewall. So it blocks all attack traffic, but it also blocks all normal traffic. And to that I say, what the? And clearly we can see what's missing here. More than 75% of traffic is good traffic. And we want good traffic to arrive at our application servers. Current success criteria only look at one side of this equation and reflects the ability to detect some of the traffic as bad traffic. Okay? A true evaluation must consider the other side, the ability to allow business continuity, the ability to distinguish between good traffic and bad traffic. So this is how a good web application firewall should look like. Allowing good traffic to pass and blocking only attack traffic. And this is where we came with our web application firewall testing framework. The concept is really to have a true evaluation of the effectiveness of the web application firewall by combining good traffic and bad traffic and measuring two parameters. One is good traffic that is being blocked. These are the false positives. And we use various sources for data for those tests, like, for example, the Gutenberg project, which contains scanned books. Okay, so we took pieces from the Bible and War and Peace and whatever. And then bad traffic being overlooked, those are false negatives, actually, which attacks are not detected by the web application firewall. And the total effectiveness is determined by looking at the balance between those two parameters. Our first design goal for the framework was simplicity. We wanted a point-and-shoot user interface. We wanted it bundled with a sample application that can be used for testing. And we wanted simple, comprehensible reports that do not require an expert to understand. And then the second one was completeness. And stateful testing was very important to us because some of the application layers attack are stateful, like cookie poisoning, cross-site request forgery, so on. And this is our idea about how a stateful test should look like, for example, in the case of cookie tampering. We have a request going through that shouldn't be blocked, that causes the server to generate a cookie with a specific value. Then a request that carries this value should again go through uninterrupted, and only when a request is generated that has a different value, it should be blocked by the device. So it was very important for us to be able to express this course of tests in our framework. The other side of completeness was application layer evasion techniques. I've mentioned that techniques like parameter pollution, complex attack vectors. Here's an example of an SQL injection attack vector that is more complex than the standard. And everything, for example, that appears in Ivan Ristik's latest paper would qualify for that and would attribute to the completeness. Third goal, flexibility. We wanted everything to be configurable. So all the tests are based on XML files that can be edited by a simple text editor. You can actually add tests and remove them by just selecting a different set of files from the existing test base. You can create your own test with the text editor, and you can actually customize the entire test base using a text editor to support a different application. We ended up with a pure Java application, again, heavy reliance on XML-based configurations. We bundled the WebGoat application together with it as a sample application. Wasn't the easiest one to go with, but we wanted an application that would be accepted as an unbiased way to represent application layer vulnerabilities. So we used that. And we use the common HTTP client by Apache to generate the traffic. So the deployment of the framework looks like that. We have an HTTP player, the WAF in the middle, and the WebGoat application. We read the configuration from the XML file, play it, and then we count both blocked attacks and blocked good traffic, and eventually generate a report. So if we expect a request to be blocked because it is signed as attack in our configuration file, it would be received by the web application firewall and then blocked. The way we know whether a specific request was blocked or not is configurable. We have some defaults put into the framework. For example, if the connection is dropped, we know that the request was blocked. This is, and this counts as a blocking. And then good traffic should just pass through the web application firewall into the application, and we should see the standard response from the application. User interface, very simple. Most important field here is the IP address or host name for the server that holds the web application. There isn't much in the test itself that relies on that being WebGoat. URLs, we didn't want to get blocked for every URL by the application, so we needed the URLs to represent something real. We needed cookies to get returned to us. This is why we used WebGoat. okay, why we bundle it with an application. It can quickly be customized to any application that you'd like. And I'll mention in future extensions one of the features that really help with that. So again, this is the GUI, very simple. You need to put in the address of the server that hosts the WebGoat application. Then you choose the name for the report, the file that holds the report. You can configure how the web application firewall represents blocking. There's a default of dropping connection. There are default related to the error code being returned by the server. It could rely on a specific string that is in the HTML response page. That's configurable. You can choose a custom set of tests, and then you have to click run, and seconds later you're ready, and you click show report, and you get the PDF with the report. Some of the things that we want to add to the framework that are not there yet, we want to generate test configuration files directly from network captures. It would allow us to grow the test base more easily. And we'd like to add more tests, especially around stateful vulnerabilities, and also increase our test base of good traffic. And last but not least, we would really like to add more evasion techniques and really cover all those techniques that have been discussed by Ivan Ristic in his paper. So we now want to actually give you a live demo of how this looks like, and we chose two scenarios. One is an IPS, and some organizations settle for an IPS as a web application firewall. I think that part of it is because the current methodology of how to test a web application firewall makes it hard to distinguish between the qualities of an IPS and the web application firewall, and you'll see it in a second. We tested Snort with the VRT certified rules, and you'll see how that scores. What we further did is we added some restrictive rules that are not in the basic rule set, and you'll see how does that affect the balance between false positive and false negative, and give you some cases why it is important to apply this kind of framework. And the second scenario that we've tested is the open source web application firewall mod security, which is considered to be an entry-level web application firewall. And again, you'll see the trade-offs there, and really something that allows an organization to get an understanding of what's the quality that the WAF provides.
Thank you, Amchai. And now we'll move to a live demo of the WAF testing framework. It is deployed very easily as a single executable. All you have to do is to execute it, and you get a simple user interface. For the IPS test, because it identifies that connections are blocked, all I really need is the host name and the port for my web application. Everything else can be stayed as default. And I'm running the test, which takes about a few seconds because everything is local on my VMs. Now, once this is done, I'm showing the report, which is a PDF report. The report has 4 parts. The first part is the methodology used by the framework. We have the I believe of the framework. What we are doing here is a brief description of the attacks we are using, and also important, the false positive techniques, things that are likely to trigger false positives in web application firewalls. The next part is the chart which contained false negative and false positive, I can see that by default it wasn't so effective against my attacks. Especially I want to focus on SQL injection and cross-site scripting that are of interest, as they are a real problem that occurs every day. And following with that, there are the results of the specific tests. You can see the URL, headers, and cookies being used in the tests. Now what I'm going to do is to enable a rule which is designed to block a SQL injection. It is a rule that was suggested by Symantec. It is quite simple, but it will recognize known patterns that will likely to appear in SQL injection attacks. And while I'm trying to let it load, I'm going to run it again against the same IPS. Okay. And when showing the report, I'll go straight to the result. I can see that at least for SQL injection and cross-site scripting, I gave a very good result. I have only 2 false negatives, which are 9% of the XSS I throw against it, and I have blocked all the SQL injection attempts that I used. And as a customer that is going to decide at this point, according to correct testing methodology, I will be quite happy. Because I say, okay, now I tuned it a bit, and it wasn't so hard, and I'm blocking all the traffic, so I can go ahead and purchase this solution because it's going to protect me against attacks. What you don't see in scanners or other testing tools that I discussed before is the fact that you will pay a price for this simplicity. We are introducing quite few false positives that are triggered because the rule is too strict. And let's look at some examples of false positives. I can see this sentence, which is quite standard English sentence. The only thing that is weird about it is this character that is considered a comment in SQL injection. So this rule decided to block it. And that shows us how easy it is to pass a test using correct methods, but it's also very easy to prove that while the blocking is very effective, I pay a price for that in my continuity of business. Even if I'm appending some textbook, if I'm in a blog or in a forum, and I just paste something that I found in a book, the presence of these characters will trigger an alert, and the WAF might block my request. The next thing I want to discuss, which was mentioned by Amichai, is stateful testing. We also included in the framework cookie-based attacks. For the sake of this demonstration, we took them aside, and I'm going to show you how an XML that contains a recording for this framework looks like. So an XML it looks with a lot of details because it's a network recording, but it's quite simple actually. It has the recording root element and a sequence that can be repeated one or more time. And a sequence represents an HTTP session that is open in the beginning and keeps the state, including all cookies that are returned from the server, it is all on the same session. If we look on a single request, we have the standard elements that we expect from such a request. We have the method, which is post in this case, protocol, the path, and some headers. One thing to mention is we indicate on each request if it's a cookie if it's an attack or not. So for this request, we expect the WAF to block it. And if it won't, we count a false negative. And for the request in the beginning, we do not indicate anything. So if the WAF will block it, we'll count it as false positive. This scenario is quite simple. We log in, do a normal request, and in this stage, we override the cookie, the authorization cookie, by a value that is called tampered, and this will tell the framework to replace the cookie with something malicious, and we expect the WAF to identify this. And we also add another attack, which is just cookie injection. This is a new session with an injected cookie. In order to point the framework to the custom tests that I've created, all we need to do is to click this button and point to the applicable folder and run the test again. Now in the report, I can see that I have 2 false negatives. One for cookie injection and one for cookie tampering. Just a note, one can argue that in Snort you have a mechanism called flow bits that can keep the state of a session. So flow bits can indeed identify the fact that a cookie is set and see that if you're sending a cookie back, it really has a set cookie direction before that. So that will probably, that should address cookie injection. However, it will not address cookie tampering because it has not enough memory to track the value of cookie. So it won't catch that. Okay, the next thing I want to show you is the test against mode security, which is considered an entry-level WAF. Okay, and since this is a web application firewall, and it's sending a blocking page back against us, we need to tell the framework how to identify that a page is blocked. So this is done by the simple XML file. We have the status code, which is for a string case of mode security, and the page content, which is some kind of string that appears in the string in the page that is returned. In order to configure the framework, I have to point to this file and rerun my tests. So again, this web application firewall it seems very effective by current testing method because it blocks all MySQL injection and XSS attacks. I have an issue with RFI, but I believe I can address that later. So again, as a customer, I am very likely to purchase the solution because I see that it's very effective against the attacks I threw against it. But this time it will come at the price of even more false positives that I had with Snort. And let's look on what kind of things that are blocked as false positives. There are common sentences with smileys that I can find all over. If they are typed, they will be blocked. And even things with just even the presence of double quotes inside will trigger this one.
We know that web application firewall testing is important. And we mentioned 2 points in time where you'd like to test it. One is before making the choice, making sure that you do the right choice, and then validating the deployment where customization is even more important. The testing methodology, and I think this is the most important statement I want everyone to take from this presentation. The testing methodology must take into consideration the real world constraints and the fact that the traffic is mostly good traffic and only part of it is bad traffic. Second thing, when we're testing web application firewall, and this is why we need specialized framework for that, is that attackers are using evasion techniques, and they are using techniques that are web application techniques. So we need a tool and a framework that focuses on these fields and on these types of attacks, and not something that is more generally about vulnerabilities. So what's the conclusion? Conclusion is that we do have a framework like this that we're going to release. It does care about real world traffic. It's very easy to use and extensible. And as I said, our plan is to release it by the end of the year as a closed source, with the test base being configurable. And then our next step would be to release it as open source native, so the community can contribute not only to the test base, but also to the functionality of the tool. Well, I think that a lot of the stuff that's there can be added with the existing library, because not all of them are necessarily there. And yes, we thought about it. We will have to probably add a component that works directly against sockets in order to do that. And actually, one of the examples that Denis showed, where you take snort for that matter, but add a rule and then see what's the balance that you get, and okay, that's too much for me. Let's pick up a different rule, and so it's very useful in that case as well.
Is there any plans to allow you to suck in something like PCAP into the XML?
That was one of the roadmap features, yes.
What was the one? Sorry.
Yeah. Well, actually, we see it as something that they can capture, translate it into the XML configuration, so it can later use the XML configuration. Anything else? Thank you very much.